Hi, in this video we're going to be looking at the multiple representations involving limits worksheet. There's only 5 questions here, but there's multiple representations. 1. 3 different ways of describing a function called h of x. And they ask me here the limit as x approaches 3 of h of x, such that this limit does not exist. Which of the following does not exist? Which of the following could be h? Okay, so in A, we're given a piecewise function, h of x equals 12 minus x for x less than 3, and 4x minus 3 for x greater than 3. So the limit as x approaches 3. So we plug in a 3 here, and we get 9, and we plug in a 3 here, and we get 9. And we say, aha, the limit is the same from both sides. But we said the limit did not exist, so we can't have a. Or we can't have 1. 1 is just out. What about 2? 2 is on a table, and I can see that there's certainly a value at 3 on this table. We also know, well, they don't tell me that this function is continuous, but I sort of feel like I'm looking at something that's continuous there, or at least defined at those places, and the point exists, but that doesn't necessarily tell me about the limit. I'm gonna say, what am I gonna say? No, I'm not sure about 2. 3 is a picture, and I can clearly see from this picture that the limit of the function does not exist at that point. So I know that this is dne. Okay, and I want to go back to 2 for a second and say something about that. If h is a piecewise linear function, h is a piecewise linear function. Well, that's interesting. Okay, so then to the left of 3, this function is decreasing, and to the right of 3, this function is increasing. This is going down towards 0. This is going up from 0. So why does that limit not exist? Which of the following could be representations of h? Well, this is equal to on both sides, but I don't know. This is 9/3, 8/3, 7/3. Oh, it's piecewise linear, so this must be 6/3 here. Yeah, no. This is a jump discontinuity then, because this piece is going down by 1/3 each time, and by the time we get to 3, the value will be 6/3 or 2, whereas as we come from the other side, we're going to have 0, so the limit does not exist there either. So 2 and 3, which is choice D for number 1. Okay, I like having to think and read those words. I really needed to read the words where it said piecewise linear, and I needed to think about the linear nature of that function given to me in the table for each of its pieces, the piece to the left of x equals 3 and the piece to the right of x equals 3. Okay, number 2, let g be a function that is decreasing for x less than 0. For x less than 0, g prime is less than 0. And for x greater than 0, g is decreasing. Okay, so we're decreasing on either side of 0. Maybe it's like this, and maybe it's like this. Oh, that's increasing. Silly me. So we're decreasing and decreasing. Okay. So let me see. We see a g of x in 1 that is defined as a piecewise function, negative x squared minus 3x over x for x not equal to 0, and 5 for x equal to 0. Okay, so here, if we do this, the limit as x approaches 0 of negative x squared minus 3x over x, and say, hey, that's the limit as x approaches 0 of negative x plus 3 over x, and then we plug our 0 in, we get negative 3. Well, the limit from both sides is negative 3, and our limit is supposed to be positive 3, right? They tell us in the stem of the problem that x approaches 0 of g of x is 3. So that can't be it. It's not 1. What about 2? Well, when I look at 2, I see a function lower, 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 lower. These values are getting lower and lower and lower. These values are getting lower and lower and lower, and that's good because we know that g is decreasing on both sides of 3, but we're also told the limit has to be 3 there. And this is going towards negative infinity. This is heading back up towards positive infinity. They're not going to reach a limit of 3 at that point. So 2 doesn't work either. What about 3? Well, I see a decreasing function. I see the limit is equal to 3, and the point is to find somewhere else. I like 3. 3 works for me. Which of the following could be a representation of g? And I say choice C. Or just to go back to this one for a second to make sure I factored it properly. I factored out a negative x, I canceled the x's, I plugged in a 0, I had 3 times negative 1, which is negative 3. Yeah, I don't like that one. Okay. So let's take a look then at question 3. And the next page says, it's much like this last one. Increasing and increasing. So we know that g prime is greater than 0 for x not equal to 1. So we want everywhere increasing except at 1. And then we see that g, the limit as x approaches 1 of g, should be 5. Which of the following could represent the function g? Okay, so 1 is again this algebraic piecewise representation, and so we want to think about the limit as x approaches 1 of g as being the limit as x approaches 1 of x squared plus 3x minus 4 over x minus 1, and that should equal the limit of x approaches 1 of 3, the other piece. Well, I don't need this is only at 3. I don't need to worry about that. So let's go back and consider then factoring this numerator, the limit as x approaches 1 of x minus 1 x plus 4 over x minus 1. So I plug in a 1 and I get 5. So I get that the limit is 5 and that's what I'm supposed to get, so I like 1. What about 2? Well, this function is supposed to be everywhere increasing with the limit equal to 5. So these values get bigger and bigger and bigger, and these values get bigger and bigger and bigger, but this is way past 5, and this is nowhere near 5, and so 2 does not work, because we need to be approaching 5 on each side. 2 does not work. What about 3? 3. Okay, so I'm everywhere increasing except at that point, and the value of that limit is 1, 2, 3, 4, 5. I like that one. So I like 1 and 3 here, and that means choice D. Choice D for problem number 3. Problem 4. Problem 4 says the graph, there are 2 graphs of f of x, which could be the table. Oh, these are 2. Okay. Which could be a table for f of x. Okay, so here I see the limit of the function as x approaches 1 is 4. So the limit is 4. Ooh, these look like 4. These look like 4. These look like 4. So not this one because the limits aren't 4. The value of the point is 7 at 1. So this one says 4. That doesn't work. This one says undefined. No, the point exists. So B for number 4. B for number 4. And for 5, I see at -1, the limit should be 3. Here the limit is not 3. -1, the limit is 3. Oh, that's good. Here the limit is 3. And here the limit is 3. So again, we're ignoring the top one, and we're looking at these bottoms. But which one has f of -1 equal to 2? This one does, so 5 is B. And that's it. That's our multiple representations. But really, I think it was worth taking a quick look at because you're going to have to confront this now. AP is making a concerted push to say, you understand this idea of limit in ways that are going back to our conversation about the rule of 4, either algebraic, numeric, or graphical in nature. Okay, let's take a look at the next one.